Hello and welcome back for the video notes for section 6.1. We're going to only be covering two sections in chapter 6. And this first one is all about verifying the identities. So we learned some identities that are listed here in chapter 5, and we're going to use these identities to prove other identities. And so we're going to have to use some of our factoring skills from algebra and some other things that we've learned throughout the years in algebra to do this. So it's basically just kind of heading in a direction and seeing what will work. And sometimes you might have to restart and erase, and that's okay. So there's two general approaches that you can do. One is one side of the equation, focus on the side of the equation with the more complicated expression and transform it until it is identical to the expression on the other side. The second approach is to transform the expressions on both sides of the equation until the resulting expressions on both sides of the equation are identical. So sometimes you'll kind of see an idea and be able to go with one approach, and sometimes the other approach might work. So I'm just going to go through how I might think of these, but you might think of other ways to prove them. So the first one is write the given expressions in terms of sine x or cosine x. So we're just getting practice using identities. So cosecant squared, I know that cosecant is equal to 1 over sine x. So I can use that to write 1 over sine squared x. We want to rewrite secant x times cotangent x. So secant x is equal to 1 over cosine x. And then that's going to get multiplied by cotangent x. We know up here is cosine over sine. So we can rewrite cotangent as cosine x over sine x. And then these cancel out, and we're left with 1 over sine x. Remember, I wanted you to write the given expressions only in terms of sine or cosine. Okay, C says 1 minus tangent x. So I can rewrite the tangent as sine x over cosine x. And then the 1 I can use to get a common denominator of cosine x. And then we can combine the fractions. So it's cosine x minus sine x all over cosine x. Okay, the next one is I want you to verify the given identity. So now I want you to verify that the left-hand side will equal the right-hand side. So strategy 1, write a given expression in terms of sine or cosine, and then simplify the expression if necessary. So I'm going to rewrite cotangent as cosine x over sine x. And secant x is 1 over cosine x. And those cancel out. So I have 1 over sine x. And that does indeed equal, cosecant x. So I manipulated the left to equal the right. B. So sine squared of a negative x plus cosine squared of x equals 1. Okay, using the identities that we learned in chapter 5, we know that sine squared of a negative x is the same as a negative sine squared of just x. Now we have plus cosine squared x equals 1. And we know that the negative sine squared x is equal to sine squared x. And then we have plus cosine squared x equals 1. And we know from the identity that this equals 1. So 1 equals 1. So you'll have to go back to chapter 5 to see the progression here of these identities of the sine squared of a negative x and negative sine squared x. Letter C, let's prove this identity here. Cosine x plus tangent x times sine of x equals secant of x. So I'm going to leave the cosine x for now. And tangent is sine x over cosine x. And then we have multiplied by sine x over, and then, so I'm going to get a cosine x common denominator. So I'm going to multiply both sides by cosine x, or multiply this by cosine x, cosine x. So cosine x, cosine x, so that's my common denominator. Plus I have sine x times sine x, so that's sine squared x over cosine x. And now when I multiply the first fraction, I've got cosine squared x plus sine squared x over cosine x when we add our fractions with common denominators. And we know the identity of cosine squared x plus sine x equals 1. So this is 1 over cosine x, and that equals secant x, which is what we were trying to prove. Now, the second part of this lesson is using another strategy with factoring. So applying a factoring technique, if possible, to a given expression. Strategy 3 is obtaining a difference of squares. So if an expression consists of a fraction whose numerator or denominator is of the form a plus b or a minus b, then we could multiply by the conjugate to get the difference of squares. Okay, and then one of the Pythagorean theorems can be applied. So let's try to verify the given identities in example 3. So we have sine cubed x equals sine x minus sine x times cosine squared x. So I notice here that these both have a sine x. So I'm going to factor out a sine x in front. So then I have 1 minus cosine squared x. And I know that this can be made with the identity here, cosine squared x plus sine squared x equals 1. And if I subtract cosine squared x from both sides, I get sine squared x equals this difference. So I'm going to replace this with sine squared x. So I have sine x times sine squared x, and that gives me sine cubed x, which is the left-hand side. And I just proved that given identity. Okay, letter E. So now we have cosine x minus sine x squared plus 2 times sine x cosine x equals 1. So cosine x minus sine x themselves, that expression is not an identity, but I could multiply this out. So I'm going to multiply this square here. So when I do, I get cosine squared x, and then I get a minus sine x cosine x another minus sine x, cosine x, and then a plus sine squared x. Plus, I'm going to bring this down here. So plus 2 sine x cosine x. And I want that to equal 1. Okay. So I'm going to regroup. I've got cosine squared x plus sine squared x. I'm going to regroup that. And then I've got 2 of these. So minus 2 sine x cosine x. And then I've got plus 2 sine x cosine x equals 1. So cosine squared x plus sine squared x equals 1. So that equals 1. And then these cancel, and so I am left with 1 equals 1. Now, I know that I'm making it look simple because I have done these for years. So it's okay to struggle a little bit and just kind of write down what you know. And like I said, if you have to cross it out or grab a new piece of paper, it's okay to start over. But struggling through it is how you're going to grow in your understanding. Okay. This next one, we've got cotangent squared x minus tangent squared x equals cosecant squared x minus secant squared x. So I'm going to use some of the identities from the front page. I'm going to use the one here that's cosecant squared x is the same as 1 plus cotangent squared x minus, and then secant squared x, I'm going to use the identity that's 1 plus tangent squared x. I'm going to distribute my negative. So 1 plus cotangent squared x minus 1 minus tangent squared x. And the ones cancel, and I'm left with cotangent squared x minus tangent squared x, which is the left-hand side. So I just proved that identity. Okay. Now I've got some differences in some sums, but they're not squares, so I can't use that the Pythagorean identity. Cotangent x minus 1, cotangent x plus 1. Let's see. I'm going to rewrite the cotangent x as cosine x over sine x, and I'm going to make this 1 into a common denominator of sine x. And then the denominator, I'm going to do the same, so it's going to be cosine x over sine x, except for it's an addition, and again turning my 1 into a sine x over sine x. So now I have cosine x minus sine x all over just sine x all over cosine x plus sine x all over sine x. And that's really taking this top fraction and multiplying by the reciprocal of the bottom fraction. So the sine x will be on top. Still being multiplied. So sine x is canceled. So now I have cosine x minus sine x over cosine x plus sine x. Oh, which is exactly what I wanted. So we just proved it. Oh, cool. Okay, let's look at E. We have 1 minus sine to the 4th x. So I don't know anything about that right offhand. And I've got cosine squared x plus cosine squared x times sine squared x. So I immediately see that I've got a cosine squared x in both of these, which I'm going to factor out. And I have 1 plus sine squared x. And this cosine squared x, what we showed in a few pages ago, that can be rewritten as 1 minus sine squared x times 1 plus sine squared x. So we actually have conjugates being multiplied together, but let's multiply these two binomials. So we have 1 plus a sine squared x minus a sine squared x minus a sine to the 4th x. And these two cancel, and we're left with what we wanted, 1 minus sine to the 4th x. And that one's proved too. So I recommend that you just kind of jump into the homework and get started and see where you can go, and send me emails or questions if you have them along the way, and catch me back for the next video.